Hello, everyone. My name is Moria. I'm from AIT. Today, we are looking at one of the projects we are working at AIT. It's a multimodal quiz generation model for educational assessments. So the case what we were looking at is we wanted to build a model that can understand video lectures. When you talk about video lectures, video lectures has different modalities within it. So how do we make sure that an AI understands this modality is important, right? So a video lecture will have audio that they will be talking about. These are all the kinds of information that that exists in the audio format, and there is also the frames, right? So whatever is shown within the video, either the professor, whatever he's showing, or even the presentations that is shown on the screen within the recording need to be understood. And what is in that presentation file is also something that we need to understand. So how do we build a model like this is the biggest question we have. So, and how do we ingest this kind of modalities into the LLM is also something that is kind of a question mark that we have. So these are the kind of challenges that we're looking at to solve within this project. And let's get into the details of what have we implemented in order for us to solve this kind of problem statements. So we use a RAG model. RAG models are used to talk with your own data. If you wanted to ingest your data into LLMs, RAG models are the techniques that a lot of people use to ingest your data into LLMs. And we need to have an embedding model. So now let's say that we upload the lecture videos. We used OpenCV to understand the frames of the video, and we used a Lava model to interpret what is shown in the each frame of the video, and we process that information. We created embeddings of the output of Lava, and we store that in a vector database. And that is what is happening, and it happens for other modalities as well. So for example, we take audio also, and the audio is processed through a whisper model, and we know what is spoken within that 4 nanosecond space. And we know, okay, this is the data from the audio, this is the frames understanding at that 4 second 4 second of time interval. We create intervals so that we can merge the modalities together, and we merge all the modalities together to understand information even better. And that is the technique that we came up with to ingest information into the LVLMs. Okay, LMMs, large multimodals. For this, the data set we have taken is the MIT lectures from Introduction to Computer Science, and these lectures are around 1 hour 20 minutes long, and these lectures are 1 hour 20 minutes long, and they were like 18 of them from what I remember. So yeah, so we implemented this model. Now we are generating quizzes from this model. So our evaluations were focused on how the retrieval is performing and how well the generation part of the LVLM is performing. So that is where we implemented two different metrics called hit rank and mean retrieval rank. We have had 91 and 82% on retrieval for textual data, and 83, 71 for image data for retrieval. And for generation, we have the kind of metric that we went with is how relevant and faithful the data is. And we have had more than 82% in all the cases for the generation evaluation as well. So in conclusion, we have one step closer to bridging the gap between understanding multimodalities within the quiz frameworks, or even understanding videos that you can record and ingest into LLMs. So we're just one step closer to that, and we're really excited to share our work with everybody. Yeah.